Next, I will introduce you to Nuvoton's platform. Currently, Nuvoton's machine learning IC are divided into three main types: the M4, M55, M1, and the A35. The M55 M1 is our newest IC featuring an NPU accelerator, provide a higher machine learning performance. The current version can run the 200 MHz with the NPU part capable of achieving an accelerator speed of 200 MHz. The M4 is our standard MCU without an NPU. Its CPU core run at 200 MHz and is suitable for handling linear AI computations. The A35 falls under our NPU platform with an 800 MHz computational capacity. It is ideal for run larger model that typically don't fit into our MCU. These larger models are more suited to be executed on our NPU platform. The M55 M1, our newest machine learning IC, features an important addition: an NPU for acceleration. Its DSP uses Arm Helium technology for computation. In terms of memory, it boasts 1.5 megabytes of SRAM and 2 megabytes of flash memory, making it the Nuvoton MCU with the largest SRAM to date. The major feature of the M55 M1 is its model protect feature, which helps to keep customer import model safe. Finally, the M55 M1 introduced three additional functions: smart motion detection, acoustic energy detection, and smart wake up. The M55 M1 used a method called XON for model protection. XON is a special area that can only be executed, not read or write by other programs. We use our Vela compiler to place our command string into the flash memory. The red section, the red section, which is accessible only to the U55, is of limit to other programs. This mechanism secure protect the user's key model access. Next, let's talk about smart motion detection. In low power mode, our system might detect an object like a rotating electric fan. This triggers the motion detector to switch from low power mode to normal mode. Using our NPU, the system infers that this is not a human, identify it is a false alarm. When the area is going to ignore, the system returns to low power mode. However, when it detects actual human movement, the motion detector again switches from low power mode to normal mode. This time, our NPU recognizes a human presence, and the system continues operation in normal mode. Here's about our acoustic energy detection. In the acoustic energy detection feature, initially there is no sound detected. When a certain decibel level is reached, acoustic energy detect a captive switch from the low power mode to normal mode. Then the NPU infers that whether the sound is of human. If it is a false detect and is a false detect or an incorrect sound, the system return to the low power mode. However, if another sound at the detect decibel level is identified as a human voice, acoustic energy detection will active again, switch the system from low power mode to normal mode operation. Okay, this is about the smart wake up. In the smart wake up feature, we use different type of sensor with the gyroscope sensor as a sample. Initially, there is no vibration. When a certain level of vibration is detected, the smart wake up activate switch the system from low power mode to normal mode. The NPU will influence whether the vibration is human indeed. If it is false alarm or an incorrect vibration, the system returns low power mode. However, if the vibration is detected again and assessed as human indeed, smart wake up will reactive transition the system from low power mode to normal mode operation. Then we have a M460, a 200 megahertz MCU without an additional NPU for acceleration. It is equipped with DSP and floating point capacity. In terms of memory, it features 5 and 12 kilobytes of SRAM and 1 megabyte of flash memory. The M460 also supports the XOM function. The A35D1 is an MPU features a dual-core A35 processors. Like a M460, it doesn't have a separate NPU for acceleration. Additionally, it includes an M4 core that can run real-time execute program at 180 MHz. In terms of memory, there are several options available, include 128 and 256 or 212 megabytes DDR memory, along with 60 gigabytes of eMMC flash memory for storage. It is also a wide range of peripherals. For HMI application, the MA35D1 can support an HD LCD and has 2D graphic acceleration and a JPEG decoder, along other features. It also supports external DDR size up to 2 gigabytes. In this slide, we can see the comparison table for each IC, heightening their respective speed. 200 megahertz at 200 megahertz for 155 and 1, and 800 megahertz for the A35, and 200 megahertz for the M460. Under the M55 and 1, we observe a higher number of megs per cycle, indicating that it is the fastest in terms of memory speed among the three. It also has the broadest range of applications, such as people counting, robotics, and so on. In this slide shows the development board created using the M55 and 1, M460, and the A35D1. The M55 and 1 has a large SRAM capacity of 1.5 megabytes, while the A35D1 with its built-in DDR has 256 megabytes of memory. All three use TensorFlow's inference engine for AI applications. The M55 and 1 additionally 3 new functions smart motion detection, acoustic energy detection, and smart wake up. This information can serve as a reference for you here.